Have you ever wanted to find the sum from 1 to 16 of 3 plus 5r plus 2 to the power of r? Well, today is your lucky day. Now, of course, we could type this into the calculator and check that it is true, but we're not going to get any marks for that. But at least it's true. So how are we going to do it then? You've got to notice that this summation is made up of an arithmetic sequence, 3 plus 5r, and a geometric sequence, 2 to the power of r. So what we're going to do is we're going to find the sum of the arithmetic sequence from 1 to 16, then the geometric sequence from 1 to 16, and then add these two answers together in the end to give us the final sum. So part 1, we are summing the first 16 terms of a sequence. Therefore, we're going to need the formula Sn. If you don't know the formula, I'll write it here, but you do get it given in the formula book, so there's no need to memorize it. We do, however, need to know what all these letters stand for. A is the first term of the sequence, N is the number of terms that we're adding together, and D is the common difference between each term of the sequence. The first term here is when r is equal to 1, so sub r equals 1 in, and we get 3 plus 5, which is 8. N is the number of terms we're adding, which is 16. And then D is the difference between the two terms, every two terms. Well, the first term is 8. When r is equal to 2, the next term is 13. So the difference between every two terms is 5. We've got A, we've got N, we've got D. Now we just need to put everything in and see what it equals. So 16 over 2, 2 lots of 8 plus 15 times 5, which is 8 times 16 plus 75, which is 8 times 91, which should be 728. Now it's time for part 2, which is the geometric series. We're adding the first 16 terms of the sequence 2 to the power of r. We're going to use the formula Sn, but this is a different Sn from before. And again, this formula is given in the formula book, so don't feel like you have to memorize it. Now please be careful, these r's are different. The r on the left is a placeholder for the summation. The r on the right is the common ratio. A still stands for the first term, and we find it in the same way as before. Sub in r equals 1, that will give you the first term. If we work out the second term by subbing in r equals 2, we'll get 4. And then the next term will be 8. So the common ratio will be 2 because we are timesing by 2 to get from one term to the next. Finally, n is 16 just as before because we're adding the first 16 terms together. So the sum of the first 16 terms will be 2 lots of 1 minus 2 to the 16 divided by 1 minus 2, which is 2 minus 2 times 2 to the 16 over minus 1, which can be simplified by dividing each term by minus 1. Don't happen to know 2 to the power of 17 off the top of my head, so I'll quickly type this into the calculator. I'll subtract 2, and then just to piece it all together, this means that the total sum, the original question, is going to be the sum of the arithmetic sequence plus the sum of the geometric sequence, which gives us, once we add them together, the final answer of 131,798 as required. Want some more?